All right, today in our notes we are looking at patterns and linear functions, and really just kind of talk about what is a linear function. So there's kind of two parts to that. We're going to talk about what it means just to be a function, and then we're also going to talk about what it means to be linear and kind of compare that to nonlinear as well. So first of all, a couple of vocabulary terms for you. They're terms that you should have seen before. We've talked about them before in math class as well as in some of your other classes, whether it's science or Project Lead the Way or anything like that. We've probably seen or heard these terms. Dependent variable and independent variable. Independent variable being the thing that you control. Independent variable is always our input. It's what we decide what that value is going to be, and it goes along the x-axis of our graphs. And then our dependent variable is what changes based on whatever the rule is or whatever the function is. And so when we do our independent variable, it goes into our function, and then our dependent variable is what changes based on that function rule. A function is a relationship where each input value has exactly one output value. So if we put in the number 2 and 5 comes out, that's what comes out every single time. That if we put in 2, we get out 5. If we put in 10, we get out 15, or whatever the case is. So where we know that every time when we put in an input value, there's a specific output value that matches it that comes out every time. A linear function is a function. So same thing. We know the input and output values. They're matched up, one input for every output. And then to make it linear, the graph is a line, and that line is not straight up and down. So linear function has a straight line, and then nonlinear function does not have a straight line. And so we're going to take a look at both of those types of examples today. So in our first example, we have a set of rectangles. It says in the diagram below, what's the relationship between the number of rectangles and then also the perimeter in which they form. And so we're going to represent that using a table, words, an equation, and a graph as well. And so as we look at this first example, we're going to start with a table and looking at that relationship. And so in our table, we have our rectangles. And our rectangles is our input or our independent variable. It's what we control. And so we have, in our specific examples here, we have an example with 1 rectangle, 2 rectangles, 3 rectangles, and 4 rectangles. And then our dependent variable, or what's changing based on that, is our perimeter. And we can see the number for each one of the examples over here. And so when we have 1 rectangle, that perimeter is 6 plus 1 is 7, plus another 6 on this side is 13, plus 1 more is 14. So when we have 1 rectangle, the perimeter is 14. Our independent variable is 1. Dependent is 14. This is our input value. This is our output value. When we have 2, then our perimeter, when we count those around, is going to be 16. And then when we have 3, our perimeter is going to be 18. And then you can see here when we have 4 rectangles, our perimeter is going to be 20. That's our output value. So there is our relationship between those demonstrated as a table. The second thing it asks for is in words, and we can see the relationship between the input value of our rectangles and the output value of our perimeter. What we're doing each time is we're taking this number right here, and we're multiplying it times 2. Right? We're however many rectangles we have, we multiply that times 2, and then we're going to add 12 to it. So multiplying it times 2 is for the top and bottom, but then every time the thing that's constant is there's always 12 on the side. And so our words for that are that the perimeter is 12 more than twice the number of rectangles. So however many rectangles there are, we're going to multiply that times 12, which accounts for we're going to multiply that times 2, and then we're going to add 12 to it. And so that's our words for it. The equation that would match that would be that y, which again is our output value, our perimeter. The perimeter is equal to 12 more, which is plus 12, then 2 times our input value. So we've got equation, we've got words that describe this, our table, and then we're going to take this table and we're going to turn it into a graph over here. And so if there was one rectangle, our perimeter was 14, and so we're going to go over to one rectangle and then up to 14 on our graph, and we're going to put our point there. So there's our first data point. And then if we had two rectangles, then 16 would be our perimeter. If we had 3 rectangles, then 18 would be our perimeter. And if we had 4 rectangles, then 20 would be our perimeter. And so this is the picture that we're asked for. We represent it using a table. Inputs on this side, outputs on the other side. Words describes the relationship between them. We know that if we take the number of rectangles and we double it, we multiply it times 2, and then we add 12, that we're going to get our perimeter each time. That's the equation that matches y equals 2x plus 12, and then there's our graph for that function. In our next example, same thing. We're looking at the data that we have. In this table, it shows the relationship between the number of photos, which is x, and so our input value is right here, and the amount of memory that's left on your camera. And so as we think about being left on your camera, we know that the more pictures you take, the less memory that you have on your camera or on your phone. And so we know that every time we take a photo, that amount is going to decrease, and that's going to be the relationship. And so there's a couple questions. Ultimately, the question that it asks is this relationship a linear function? It is the relationship a linear function. So we already talked about there's kind of two things we're checking for. First of all, is it a function? A function means that every input value has one output value. So when we put in 0 to whatever our function rule is, or whatever our equation is, which we'll write here in just a second, what comes out each time? 512 comes out each time. And so every time we put in 0, 512 comes out. There's never a time that we put in 0 and something else comes out. If we put in 1, 509 comes out. If we put in 2, 506 comes out. If we put in 3, 503 comes out. And so that makes it a function. Every input value has exactly one output value. There's never a time that we put in 3 and we get out something different besides 503. So that makes it a function. Each input has one output. And then what makes it linear is, does it change by the same amount every time? So when we write linear functions, or when we're finding that change, we do the change in y over the change in x, and what we're looking for is, does that stay consistent each time? And so our change in our y value goes down 3, and then from here to here also down 3, from here to here also down 3, and our change in x goes up 1, and up 1, and up 1. And so this first change, to go from 0 and 512 to 1 and 509, would be negative 3 over 1. The second change would also be negative 3 over 1, and the third change would also be negative 3 over 1. And so our change stayed the same. It was consistent. It was constant throughout. And so our function is going to be linear because we have the same change. So, is the relationship a linear function? Yes, it is. So that's our first part of our answer. And then secondly, we are asked to use words and an equation and a graph to describe the relationship. In our words, we can tell that every time we take a picture, we lose 3 megabytes of memory. And so what happens is we start at 512, and we're going to take away 3 every time we take a photo. And so the amount of memory, and they use megabytes to represent our memory, the amount of memory left on the chip is 512 minus 3 times however many photos we take, the number of photos taken. So there's our words that describe what's going on. Our relationship for Y looks like this. Y, our megabytes, our memory that's left on the chip, is 512. And then we're going to take away 3 megabytes of memory for every photo that's taken, or every X photo that's taken. And then on the graph, we're just transferring over what we already have in our table. 0, 512. So if we take 0 photos, there would be 512 megabytes of memory left. So we put that point on there. If we take 1 photo, we'd be at 509. Which should be about right here. And then if we take 2 photos, we'd be at 506. So is that point. If we take 3 photos, we'd be at 503. It's right here. And even just the picture of our graph, linear function, that it forms a straight line when we are representing it. Alright, so that's linear functions. In our next video, we're going to take a look at nonlinear functions and just how we can look at the difference between those two.